Now we'll assign different types of load in our structure. So first of all, I will assign load on our slab. So to assign load on our slab, I'll just go here as select. First of all, I'll select all of our slab member. Properties, slab section. First of all, I will select staircase and normal slab. Then click select. You'll see total 25 shell have been selected. Now I'll go assign shell load. So shell load means the load will be applied as an area load. Then uniform. Okay. Now which types of load we want to assign here? First of all, I want to assign floor finish. Okay, floor finish. So actually, what is the way or how you are able to calculate floor finish load? Let me open a pen. If already I have calculated about that, so of per inch thickness 12.5 lb per square feet. So 12.5 lb per square feet or 12.5 pound per square feet load will be applied for floor finish. If you need to calculate that, you are able to calculate it. So let's consider we have when we have a slab here, we have floor finish in two sides. Here for sling, in below slab you will provide sling plaster, right? Also in top you will provide minimum 1.5 inch thickness or 2 inch thickness for your upper portion finishing or for tiles work or any other work actually. So what is the issue here? If we consider 2 inch floor finish, or then we'll apply that value with 2, that means 25. Clear? It's up to you that how much floor finish you will provide. It's totally depend on you. So here I'll provide 25. Then click here replace existing load. They have 3 options available. One is add to existing load. That means if you already have these types of load, I mean floor, if you have already floor finish load pattern, then if you click here, this load will be added with that. Otherwise, if you use that option, then it will be replaced with your existing load, and if you select click on that option, then it will be deleted. So I'll click replace existing load. It's safe. Okay, it's a safe procedure because sometimes if we made any mistake, then this load will not be added with that. It will be replaced. So I'll click apply. See, everywhere we have provided load. Now I will only select slab, then click. So only we have selected slab portion, and you may see here 21 shell have been selected. So when we have selected slab portion, now we will provide our live load. So how will calculate or how will know about our live load? We will go to our code. If you follow your code, I'm following this code. So if you follow your code, then they have option chapter 4 live loads. Okay, I'll click here and I'll just go bottom, and here all load are given. See, all load given in PSF and kilonewton per square meter in both way. So apartments, see residential, I will just go for it. This is a residential building, I'll go to in residential section here, residential. So from that point to that point, we have value for residential, and from here, from that point to that point, we have a roof. So first of all, I'll go for, as we are providing load for our floor slab, then we'll see that option. Okay, so here 1 and 2 family dwelling, uninhabitable athies without a storage, then 10 psf or 0.48 kilonewton per square meter. Then I think for my case, habitable athies and sleeping area 3, all other areas except a staircase without a staircase. So I prefer to provide that value, because initially I don't know which room they will use for sleeping, which room they use for other uses. Okay, and so I think I'll provide this load for all of our slab. So I'll just come here for live load. Now see, this load is less than 3, that means 1.92, that means 3. So what we'll do, actually we'll use here 40 and live load less than 3 kilonewton, we'll use that option. Okay, live load less than 3 kilonewton per square meter. Okay, so simply click here, okay, already have provided, because that site has been selected. So here this value is visible here. So done. Now we'll go for floor finish. So how we'll provide our floor finish, I will show you about only that floor or that slab, and you will calculate that as per yourself. Suppose if I just here, this is our slab area, or this is our area. Now how we can provide our that load? We have two ways. We will provide that load in this way, okay, as a line load. Okay, how it's available here. Otherwise we are able to provide that load as if area load. It's totally depend on you, that how you will provide that load as a line load, or the load same as available here, or say it's acting same as available here. Otherwise, if you are able to provide your load as a area load. Now if you want to provide that load as a line load, then you have to create some null line like that. Okay, you have to create some null line like that, and on it we'll provide our load. So let me show you how. Suppose we'll provide load for that all. that all. So I will just come here, and from any reference from that point I'll see what is the distance. 9 feet and 11 inch, let's say 12 feet. So I'll just come here and I'll take 2 point, draw joint object, then 9 feet 11 inch, that means 10 feet. So I'll minus 120 inch. 10 feet means minus 120. Just click here and click here. So we got 2 point. Now I'll click here and type frame and property none. Okay, a none line will create here and click here. So we got a none line here. It's have no value, no property modifier, no value, no self weight, nothing. Just we'll use that line to draw our load. And also if you just come here and if you draw that line, okay, let me draw that line by none. Suppose from that point to, okay, I'll just go ahead, draw snap option and use perpendicular option. Where is the perpendicular option? Here, perpendicular projection. Okay, apply. See here, perpendicular. Skip and again. Okay, without measurement I have just selected randomly, but for your case you will measure that at how much distance away this wall is and how much distance away this wall is, and then draw it. So I have considered only the 3 all, that all, that all, that all, and that all. Now how will provide that load? Actually I'll calculate that weight. So if I calculate that weight, it will be, suppose it's 10 feet height, a wall will provide that load as a linear load. It's 1 feet width, 10 feet or 9 feet, suppose 10 feet height, and its thickness is its thickness will be 1 feet. That means from that point to that point, and its thickness will be 6 inch, suppose 6 inch. So how much volume will get? 1 and 10, that means 10, and 6 inch means 0.5, that means 5, total 5. So 5 CFT cubic feet will get its volume. And now what is this? Its weight actually. Five and its unit weight. So we know a unit weights of brick wall is almost 120. So it will be 600. Okay, and now if I divided that with 10, so it's 60. That means if we take a wall, its thickness is 6 inch and its weight per square feet will be 60 psf. Clear? 60 pounds per feet. So then if you just multiply your all height with that value, then you will get your total value. So as we have wall, and from that point to that point this is slab, and they have a slab area. So we have made 6 inch slab, so our total height will be 9.5. So 9.5 feet. So 570. Clear? 570 load. So I'll just come here. Now I'll select that all, null all, and I'll just go assign frame load, distributed load, and the load will be partition all load, and how much load? It should be force, gravity load, replace existing load. And here how much load? Load will be 0.570 because that value is in pound, so we are providing that value in keep. Okay, then just apply. See, here we have applied at our load. And also if you want to see here in 3D, no, just go here, partition all, apply. Just see the load we have applied it is also visible here. Clear? So in this way we are able to do it. But I'll press Ctrl Z and I'll select, I'll delete them, because if I follow this procedure it will take huge time. So when you will go for professional design, I'll request you, please provide your load in this way. Provide your load in this way. Why? Because if we provide load in this way, then our all load here, or all load application will be very professional or very perfect. Now I will follow another procedure. What is the procedure? I will use that load as a area load. So how I will calculate that load as area load? So already we have seen that weight of per feet is almost 600 or 570 pound, right? So now I will find out all length and then I will apply that load. So how? I will just from that point to that point, 3 feet 6 inch, then 4 feet 3 inch, let's calculate it, 3.5 plus 2.5 plus 16 feet 4 inch plus 12 feet 8 inch and only available. Actually that all and that all are same as that all, that's why I have taken 16.33. then again take for that all, almost it will be of 3 feet plus 3 feet. Okay, so it is total 56. Now I will multiply that length with 570. This is a total load on that slab. Then now I'll divided that load with our area. I'll just, this is we have taken our assumed area. I'll right click. You may apply with length into length and width. Okay, length into width to find out its area, but I'll use the quick properties of our software and see here. This is our area, 30380 square feet. So I will apply. Divided by 38084. So our partition or load for that slab will be 84, but it's not a exact, or this is the approximate procedure. This is not a actual procedure, because we have load, I mean we have huge load here, but here almost we have zero load, or load available, this is very less. Now the effect on that beam and effect of that beam will not be same, right? So if we provide load as a line load, it will be very accurate and it will be almost 100% accurate. So I'll request you to provide that load as a line load. Okay, and to complete our procedure, or to complete our working procedure, I have skipped many things, like here that I have skipped that extension, and I have also skipped that here some extension. So I'll request to here I have skipped that extension actually. So I'll request to draw it as yourself. It's very easy. It's very easy because here we have a slab. Now just take some point here, a point, and take a rectangular to draw slab. I hope you will be able to draw a slab now. Now when we got that our load is 84.12, that means 85. So again I'll select all of our slab section, and go assign. Now we'll go for a staircase. The all types of load need to apply, we have already applied it, and if you have different types of load, you are able to apply it. And now I'll select a staircase very carefully. Done. See, 4 shell have been selected. Now see, for a staircase, 100 PSF or 4.79 kilonewton per square meter. But for 1 and 2 family dwellings, if you have 1 and 2 family residential only, then you are allowed to apply 40. But as we have a multiple unit floor plan, here you can see we have a multiple unit floor plan, almost 5 unit floor plan here. So for that 5 unit floor plan, we are not able to do it. So what we'll do now, we'll go for 100 PSF, right? That one. So we'll go for 100 PSF for a staircase. And here, so this value is live load, this value is greater than 3 kilonewton. 100 PSF or LB. Perfect. So everything is okay, just click apply. See here, load have been applied. Now we have to provide partitional load here also. Here, so partitional, you will calculate that how much load will be applied at here. Here I am assuming 85, same as we have calculated previously, 85. And here we have to provide some dead load. Why? Because here we have, this is the provided slab thickness only, but over slab we have riser and red, right? So also we have this weight. So you may able to calculate that value as a engineer. You should know it. So already I have calculated, and this value is almost 31.25 or 31 something lb per feet square. So I'll provide that value also. Provide that value as a dead load. 31. Apply. So done. We have provided every types of load we need to provide. Now I'll go to bottom floor, and here I'll select all of our grade beam and I'll provide load on it. So here I'll go select and then frame section, grade beam, select, assign, frame load, distributed load, partitional load, and we will consider that we have 5 inch all over that beam, and it's 0.57 already we know as we have calculated. Then just click apply. Okay, done. So we have perfectly applied it all of our load. And also if you need to apply any other load, or if you need to modify any other load, so you can do it as per yourself. It's very easy, and I hope you will be able to do it. So done. We have done everything, and in next lecture we'll go for replicating our model, and we'll change load from our top floor. We'll modify our model and we'll complete everything. So thank you very much.